up, everybody? This is Tech G back with another video. And in this video, we're going to be talking about bias and discrimination in data sets and AI models. So let's get into it. All right, so let's talk about something most people don't associate with artificial intelligence, and that is bias. So when we think about AI, we often imagine perfectly logical, objective machines calculating numbers, making decisions, and solving problems without emotion or judgment. But here's the twist: AI is only as good or bad as the data and humans behind it. And that means bias isn't just possible in AI, it's inevitable if we're not careful. So, in this video, we're going to explore what bias in AI actually means, where it comes from, how it can lead to discrimination, and most importantly, what can we do about it? Whether you're building AI systems or just using them, this is a topic that you need to know. So, let's go ahead and break it down. First, what do we mean by bias in AI? So, in everyday life, bias, this usually means having an unfair preference or prejudice. In AI, it's a bit more technical, but just as impactful. So, bias in AI, this refers to systematic errors in the output of a model that unfairly favors one group over another. So, in plain terms, if your AI treats some people better or worse than others based on factors like race, gender, age, or background, then that's a biased system. And sometimes the bias is subtle. Sometimes it's shockingly obvious. Either way, it's a problem that can have real world consequences. Now, before we dive into where bias comes from, let's look at some examples where things went wrong. We have facial recognition. So, studies by MIT and others found that commercial facial recognition systems were significantly less accurate at identifying Black and brown faces, especially for women. In one case, error rates for white males were under 1%, while for Black females, it was over 35%. And that's not just a bug, this is a trust and safety issue. Another example is hiring algorithms that discriminate. So in 2018, Amazon scrapped an internal recruiting tool after discovering it downgraded resumes with the word women's in it, as in women's chess club captain. Now, why was this? Well, the model had trained on resumes submitted over a decade, which were mostly by men. So essentially, the algorithm had come to learn that male equals good candidate and women equals bad candidate. And then there's healthcare algorithms that have racial bias. So a widely used healthcare risk prediction algorithm underestimated the health needs of Black patients. And as a result, fewer Black patients were identified for extra care, even though they were just as sick as white patients. Now, the issue, the algorithm used healthcare costs as a proxy for healthcare needs, but historically, Black patients have received less care, so their costs were lower. So now that we've seen how bias can show up in real systems, let's unpack the key sources of bias in AI. And they generally fall into two broad categories. You have bias in data and bias in models and development processes. So let's go ahead and dig a little deeper into both. And we're going to start with bias in data. So let's get one thing straight. AI learns from data. That means if the data is flawed, the AI will be too. So always remember, garbage in and garbage out. And here are some ways bias can creep into data sets. So you have historical biases, and this happens when the data set reflects past discrimination or inequality. So an example would be if you train a hiring algorithm on data from a company that's hired mostly men, your AI will learn that men are better candidates. Now, it's not malicious, it's just learning the pattern it sees. But those patterns reflect historical inequality. And then you have sampling bias. And this occurs when your data set is not representative of the real world population. So an example would be if you build a voice assistant using only American English speakers, it may struggle to understand accents or non-native speakers. And the bottom line, if your data set leaves people out, so too will your model. Then you have labeling bias. So in supervised learning, humans label the data. But guess what? Humans can be biased, whether intentionally or not. So an example would be in sentiment analysis, labeling a comment like "you're loud" as negative might reflect cultural or personal bias. And labeling bias, this often reflects the assumptions of the annotators, and that's a problem when those labels are used to train AI. And then you have measurement bias. And this happens when the features used in the data do not accurately reflect what you're trying to measure. So an example would be using zip codes as a proxy for income or credit worthiness. This might encode racial or socioeconomic bias into your model. And you might think that your model is neutral, but the inputs are always skewed. Now, even with good data, bias can still sneak in during development and deployment. And we have what is called algorithmic bias. So some algorithms, they inherently favor majority patterns in the data and ignore outliers. An example of this would be a model that is trained on 90% male data might not learn enough about female patterns because it focuses on the most common data. Then you have what is called a training imbalance. So if a model sees more examples of one group during training, it may perform better for that group. So think of it like this. If your model saw 10,000 photos of dogs and only 100 of cats, it'll be much better at identifying dogs. Now that's fine for pet pictures, but dangerous in healthcare, criminal justice, or hiring. You have what is called feature selection bias. So sometimes the features that developers choose to include in the model can introduce bias, whether intentionally or unintentionally. So an example would be including race or gender as a predictor, even indirectly, because this can lead to discriminatory results. You have what is called evaluation bias. So if you test AI on the same kind of data it was trained on, it might look great until it fails in the real world. An example of this would be your facial recognition that works on your test set, but it struggles in the wild with people of different ethnicities or lighting conditions. And this is why diverse testing is crucial. Then you have what is called bias in the development team. So here's the hard truth. Who builds the AI? This actually matters. So if your team lacks diversity in gender, race, culture, and lived experience, you're more likely to overlook key risks and biases. So diverse teams equals better awareness, which overall equals better AI. So now you might be thinking, okay, bias does exist, but is it really that serious? And the answer is absolutely. And here's why. Bias can harm real people. So whether it's denying someone a loan, flagging someone unfairly as a security risk, or misdiagnosing a patient, AI bias does have real world consequences. Also, it can undermine trust. So if people don't trust AI to treat them fairly, they won't use it. And trust is essential for widespread adoption. Also, it's an ethical responsibility. So just because something is technically possible doesn't mean it's morally right. Building fair AI isn't optional. This is a responsibility. And then there are legal and regulatory risks. So governments and regulators are starting to crack down on biased algorithms, and companies that ignore bias, they could face fines, lawsuits, or bans. So that leads us to asking, what can we do about it? Well, bias might be inevitable, but it's not unfixable. So here's how we can fight back. First thing you can do is you can audit your data. So you can look for imbalances, gaps, or historical patterns in your data set, and then ask who is missing and who might be harmed. Then you can balance the training set. So you want to make sure your data sets include diverse examples across age, gender, race, language, geography, etc. You also want to use fairness aware algorithms. So some algorithms are specifically designed to reduce bias. So look into fairness metrics and debiasing techniques during training. You also want to regularly test your model. So don't just look at accuracy. Check how well it performs across different groups. If there's a big gap, you want to dig deeper. You also want to include diverse perspectives. So build diverse teams, bring in ethics, social scientists, and community representatives, not just engineers. Also, be transparent. Document your data sources, assumptions, and known limitations, and then publish model cards or fairness reports. Do you want to empower users? So give people some level of control over how AI affects them. Include opt-outs, explanations, and appeal mechanisms. All right, so let's go ahead and wrap all this up. Bias in AI isn't a distant, abstract problem. It's happening right now in systems we use every single day. And if we're not intentional about recognizing it, addressing it, and learning from it, the consequences can be serious. But there is good news. We have the tools, the knowledge, and awareness to do better. So let's build AI that doesn't just work, but works fairly. Let's create systems that don't just scale, but scale ethically. And let's remember that behind every data point is a real person, and behind every algorithm is a choice we get to make, because ethical and responsible AI isn't a feature, it's the foundation. Now, with that being said, let's do some check on learning. So the first question is, which of the following is a common source of bias in AI models? Is it using open source libraries? Is it collecting data only from one demographic group? Is it training a model with high performance GPUs? Or is it choosing a popular machine learning algorithm? And the correct answer is it is collecting data only from one demographic group. So bias, this often arises when training data isn't diverse or representative of the real world population. If the data only reflects one demographic, the AI model may underperform or make unfair decisions for underrepresented groups. Next question. An AI system trained on historical hiring data shows a strong preference for male candidates over equally qualified female candidates. What is the most likely cause of this issue? Is it overfitting during model training? Is it data encryption errors? Is it bias that is present in the historical training data? Or is it a bug in the UI design? And the correct answer is bias is present in the historical training data. So if past hiring decisions were biased and the AI model was trained on that data without correction, it will likely replicate or even amplify those biases. And this is a classic case of historical bias in data sets. And our final question is, which practice can help reduce bias and discrimination in AI models? Is it avoiding transparency to prevent misuse? Is it using the largest available data set regardless of quality? Is it relying solely on automated data labeling tools? Or is it auditing data sets and testing model outputs across different demographic groups? And the correct answer is it is auditing data sets and testing model outputs across different demographic groups. So ethical AI development requires auditing and testing for fairness, regularly evaluating both data sets and model predictions across different groups. This helps detect and reduce bias, ensuring the system is fair and responsible.